Hello, algebra students. This video is for our quadratic formula lesson. I do want to start off by saying that today, which is Monday, November 23rd, was our first day of having our live classes for algebra. The classes would be at 10 o'clock and at 2 o'clock. Unfortunately, I did not see anyone today. But if you would like to join the class live and go through these notes live with us, please look for that link that's been posted in our Google Classroom to join the video call so that you can go through this lesson with me, and so we can ask you questions, you can ask questions, and just be a part of the learning process. That said, you are watching this at a later time, so we will go ahead and get started with these notes. Before we get into quadratic formula, we're going to start off with the review questions. There's two here, but I'm just, for this video, going to have you focus on number 1. Number 2 is down there if you want to try that one as well, but go ahead and make sure you try number 1. Pause the video now, and then we'll talk about it in a moment. All right, number 1 says solve by factoring. Last week we learned how you can use factoring to help you solve these quadratic equations. The first step is to make sure that the equation is equal to 0, which it already is, and then we want to factor the quadratic. When I go to factor this, I'm going to have 2 parentheses. Let me move this a little bit. There we go. 2 sets of parentheses here that my quadratic will be in. Because it's x squared, I know it's going to be x and x, since x times x gives me x squared. For the numbers that come after, I'm looking for a pair of numbers that multiply to 4 and that can combine to a positive 5. In this case, it would be a positive 4 and a positive 1. It does not matter the order you put those in. So I've just got my plus 4, my plus 1. And then all of that still equals 0. After that, because this times this equals 0, I know that either x plus 4 must equal 0 or x plus 1 equals 0. When we go to solve each of these equations, we get x equals negative 4. And then for this equation, when you subtract 1 on both sides, you get x equals negative 1. So my final answer is x must be a number that is either negative 1 or negative 4 or negative 1. Now that we have reviewed how you solve quadratic equations by factoring, we're going to come down here. And before I write that objective, I'm going to have you go ahead and solve this quadratic equation by factoring. Well, this one here is real similar to this one up here. I'm going to start off by factoring the quadratic. Again, we know it's going to be x and x, since x times x gives me x squared. These numbers here, similar to before, are 2 numbers that multiply to give you 4, and this time they combine to give you a positive 6. Well, if we're having trouble coming up with factors of 4 that do that, let's make ourselves a list. There's 1 times 4, but that can't combine to give me 6. And then there's 2 times 2, but that also can't combine to give me 6. So we have a problem here. I cannot solve this by factoring because there's no way to factor this quadratic expression. When we talked about solving by factoring, I had mentioned that there are multiple ways you can solve quadratic equations. One way you can solve quadratic equations is by factoring. The upside of factoring, especially for equations like this, is it's pretty quick, right? It doesn't take too long to factor this. Those equations are real easy to solve. So it's a quick way to get to your answer. The problem with solving by factoring is, as we can see down here, it does not work for everything. The first way we learned how to solve quadratic equations is by factoring. The second way, the way we're learning today, is how you solve quadratic equations using quadratic formula. So there are 2 ways we're going to focus on in this class for solving quadratic equations. And the second is with the quadratic formula. So there are 2 ways to solve. One is by factoring. The second way is the quadratic formula. I do want to mention that there are more than 2 ways you can solve quadratic equations. One of the fun things you get to see in Algebra 2 is they talk a lot more about quadratic equations, so you'll see other ways you can solve these. These are the 2 we focus on in Algebra 1. So we know factoring. Quadratic formula is what we are looking at today. The great thing about quadratic formula is it will work for every single quadratic equation. So you're never going to have situations like this where you can't use it. The downside of the quadratic formula is the quadratic formula looks like this. It starts off, with x equals, because what we're trying to do is solve for x, remember? It goes x equals negative b plus or minus, which I need a fun looking symbol like this to insert right now. Thank you. Plus or minus the square root of b squared minus 4ac, and then all of this is divided by 2a. Here it is. So I've had some students call this the almighty formula. They said that's how they learned it, which I just thought was so fun. But it's quite a big formula, right? So this is the downside of quadratic formula is there's a lot of math you have to do to figure out what x equals when you're using this. Now, when we are using this formula here, we've got A, B, and C. If you remember from last week, that was something we were practicing, was identifying A, B, and C. It comes from that quadratic equation form. We learned last week that when you're talking about quadratic equations, they're always in the form ax squared plus bx plus c. And then if it's an equation, it must equal 0. So I've got this right here is my form for quadratic equations. So A, B, and C come from those 3 numbers there. And then I even got a separate note. If it's a quadratic equation, it must equal 0. So we're going to look at these 2 examples together. The directions say solve using the quadratic formula. I do want to point out that these are equations you could also solve by factoring. So if you're looking at this saying, oh my God, why is she doing all this? Factoring is so much easier. I may agree with you, but I'm starting off with these because we want to learn how to use quadratic formula, because if you remember, factoring does not work for everything. So we want to be able to do this both ways. So starting off with quadratic formula, one of the first things I want to do is figure out what A, B, and C are. When you're looking at the equation, just like when you're factoring, sometimes it equals 0. That makes it real easy. If you have an equation that does not equal 0, you might have to do some moving of the terms, some solving to make it equal 0 before you can start using your formula. Since it's already equal to 0, I'm going to go ahead and start by identifying A, B, and C. A is always the number in front of x squared. So in this case, that is the number 1. B is then going to be the number 5. And then C is the number 4. So I'm just using 1, 5, and 4. Once you've got your A, B, and your C, your next step is going to be substituting it into the quadratic formula. For some students, it helps just by copying it down. Ooh, not like that. Copying it down on your paper just to make sure you've got everything in the right spot. So I'm going to do that, and then I'm going to switch out A, B, and C with these numbers we found. So starting off with B, B is the number 5. So I'm going to take out my B, make it a number 5. B squared, again, well, B is 5, so I'll put my 5 there. We've got 4AC. A is the number 1, and C is the number 4. Remember last week we were practicing just figuring out the square root part here. So earlier we had mentioned 4AC means 4 times A times C. So I'm going to change this, instead of 4 times A times C, we're going to say 4 times 1 times 4, and then get rid of that there. I've got a lot of parentheses. There we go. The last part down here, the 2a, a is still the number 1. So we can put our 1 there. The rest of this problem is just going to be us figuring out what this equals here. When you go to do the math, we want to start off inside the square root here. That is why we were practicing figuring out the square roots last week. So to start us off, I've still got my x. I still have equals. I'm going to go ahead and my fraction. Oh my goodness. So I'm still going to have that -5. I am still going to have that plus or minus sign. Oh my goodness. Oh, I gotta say it, I missed my whiteboard. We still have the plus or minus sign, and then after that plus or minus, we're gonna start working on this square root. So, can I do it? Please, please. I'm just gonna copy this. Okay, so after my square root, I want to simplify as much as I can. So instead of that 5 squared, I can say, well, 5 squared is 5 times 5. That's 25. And then after that, I've got -4 times 1 times 4. Well, 4 times 1 is 4. And 4 times 4 is 16. So we get 25 minus 16 all over. It says 2 times 1, but we can go ahead and multiply that too. 2 times 1 is 2. I'm going to keep the strategy of just copying and pasting. So remember, we're just going to keep going until we can't do any more. So looking at this next part here, I've literally copied it all down. It brings a new meaning to copy everything down. But looking at this, instead of having that 25 minus 16, we can actually do that math. 25 minus 16 is 9. I'm going to copy it all down again. Do you see any other math we can do here? Well, I've still got my -5. I copied down. My plus or minus I copied down. But instead of saying the square root of 9, well, the square root of 9 is equal to 3. And notice I got rid of that square root sign. Thank goodness. But I got rid of that square root sign because we've taken the square root. We're saying the square root of 9 equals 3. So at this point, I have done all the math with our square root, and I'm just left with this here. The next part has to do with that plus or minus sign, and we saw how that plus or minus sign works in that last lesson video. Do you remember? Well, plus or minus means exactly what you think it means. It means, I'm going to switch over to the pen and see how this goes. It means we're going to write this 2 different ways. One way we're going to write it is with a plus sign. So I'm going to write -5 plus 3 all over 2. And the other way it works is with a minus sign. So I'm going to write -5 minus 3 all over 2. The rest of this is just figuring out what these two fractions equal. So the first one says -5 plus 3. Well, -5 plus 3 is -2. And -2 divided by 2 equals -1. My other one here, -5 minus 3. Well, -5 minus 3 gives me -8. And then -8 divided by 2. Well, -8 divided by 2 gives me -4. So we're left with, drum roll please, x, no, we're not doing this with the pen anymore. We've got x equals -1 or -4. The last thing I want to point out for this problem is just like when we were solving by factoring, we've got a possibility of 2 answers. And you're getting those 2 answers because you're splitting it up into 2 different fractions. But notice this equation. We had x squared plus 5x plus 4 equals 0. Did you catch on that that looked familiar? Looked familiar because, back here, it's the same equation. Notice when you solved by factoring, you got -4 and -1. When you solved by quadratic formula, -4, -1. So same answer. Two methods to getting to that answer, but we're getting that same answer at the end. We talked about this some. It's reminding me of when we talked about solving systems of equations. Remember how we had those different methods and we said it doesn't matter which method you solve with, you're going to get the same end result. Same idea here. Doesn't matter which method you're solving with, you're going to get the end result. I would argue for this equation, factoring would be a lot easier than quadratic formula, but there's some students who just really love quadratic formula, believe it or not, and you could use quadratic formula and get that same answer. So this was our first example. I'm thinking I'm going to start number 2 and then have you finish it up. For number 2, speaking of starting number 2, how would we need to start number 2? We talked about it a little bit earlier. Well, for number 2, notice that this equation right now is not in our quadratic equation form. I need to start by changing the way this equation looks, and I do that by setting it equal to 0. In order to set it equal to 0, I need to get rid of that 7m. That means I'm going to need to subtract 7m on both sides of my equation. My God, you all probably think I can't type. Minus 7m. When we do that, what are we left with? Well, on this left side here, I've got 2m squared minus 7m. We cannot subtract those because this is m squared. The other one is m. They have different exponents, so they're not like terms. So I'm just going to write it all down. I'm going to write 2m squared minus 7m. Now, on the other side of our equation, I've got 7m minus 7m, 7m minus 7m. That equals 0. It cancels out. And so I'm just going to say equals 0. Just like that, now I've got this equation in our quadratic form. Now it's looking like this up here. Once we've done that, you remember what comes next? Get in this text box ready because the next thing we're going to do is identify A, B, and C. Looking at this equation here, I can see that A is the number 2, B is the number negative 7m, or sorry, I said negative 7m, but B is the number negative 7. C, well, notice I'm missing C. There's no term that comes after that 7m. So if it's missing, C is the number 0. So I've got our A, B, and C. After that comes our quadratic formula. I'm not about to type this out again. I am going to copy it and paste it. Nope, I did this before. I have to switch to equation. And now I'm going to paste it right here. I think, especially if you're doing this on paper, it helps to have it right in front of you, at least right when you're starting learning this for the first time. That way, it will help make sure that you've got all your numbers in the correct spot. One of the biggest mistakes I see students make on these is they'll put the numbers in the wrong places. So, for example, up here, instead of -5, they might write -4 or -1. So having that formula helps make sure you've got everything in the right location. Also, being able to copy and paste it does that as well. So now that I've got my formula, just like before, I'm going to substitute these 3 numbers. So wherever I see a B, I'm going to change the B to a -7. Now be careful. What is this? Be careful. What is this going to look like after we substitute B equals -7? Well, it says negative B. So I want negative -7. Well, -7, I could write that if I want, but -7 is the same thing as +7. So I'm just going to go ahead and put a +7 there. We've got 7 plus or minus square root of B squared. Well, again, our B is the number -7. I'm putting parentheses around that because when we go to do the next part, which is squaring, we want to make sure we're squaring -7 and not just 7. So putting those parentheses there show you're including the negative sign in your squaring. We've got -7 squared minus 4 times A times C. Let's substitute those numbers in. A is the number 2. C is the number 0. And then my last part, 2A, well, 2A is 2, so we get 2 times 2. Now the next part is doing some of this math. I'm going to put this down here. Oh my gosh. There we go. It's a learning process for me as well. I'm sorry. I'll get better, I promise. So we've got this right here. I'm going to work on my square root next. So I'm going to take this part out, and let's start working on simplifying that. Well, inside my square root, I see -7 squared, which we were talking about a moment ago. -7 squared equals what? Well, -7 squared is -7 times -7, which equals 49. After that, we've got -4 times 2 times 0. What's that going to give us? Well, 4 times 2 is 8, but anything times 0 is 0. So all of that's going to work out to be 0. Now I can write -0 there, but subtracting 0 is nothing. So subtracting nothing isn't really going to make a difference in this problem. You could write 49 minus 0 if you want, but in the very next step, you're just going to be saying 49 minus 0 is the same thing as 49. So I'm not going to worry about writing that -0. I could also come down here and go ahead and say 2 times 2 is 4. So we've got all of this here. Our next step, do you know what I want to do next? Oh my God. Well, as I was struggling with that, hopefully you were saying you want to square root 49. I've figured out what's inside the square root. All that's left is taking that square root. So I could say the square root of 49 is equal to 7. So we get x equals 7 plus or minus 7 all over 4. Go ahead at this point, pause the video, finish this up, and see what you get for what our variable equals. All right, so when we go to finish this, we're going to have one fraction that says x equals 7 plus 7 all over 4. And you're going to have another fraction that says x equals 7 minus 7 all over 4. For this first one here, x equals 7 plus 7 all over 4. Well, 7 plus 7 is the same thing as 14 over 4. We could simplify that by dividing by 2. When you divide by 2, you get 7/2. You could also write it as a decimal if you want. The decimal would be 3.5. This one here, 7 minus 7 divided by 4. Well, 7 minus 7 is 0, and 0 divided by 4 is just 0. Now, I was using x equals, and the main reason I was using that was because I had just copied it from up here. But notice in this problem, our variable is m, so you might want to change all of these x's to m's. It's okay if the work, though, if you have x running through your paper like I did. But for that final answer, I do want to make sure I'm going to say, for my final answer, we've got m equals, our first one was 7/2. Or m could equal 0. Now, I do want to mention, just like with any equation, if you just had a lot of time on your hands and you wanted to check your quadratic equations, you could check these the same way you check any equation, and that would be using substitution. So for this one right here, I'm going to choose 0 because it's a real easy example to show how you could check. If we wanted to check that m equals 0 and that I had gotten the right answer, all I have to do is substitute 0 for m. So for this equation here, I'm going to use that original equation, and it would just say 2 times 0 squared equals 7 times 0. Well, 7 times 0 gives me 0, so I know this right side equals 0. On the left side, 0 squared is 0 times 0. That equals 0. And then 2 times 0 also gives me 0. So I'm given a statement that says something that's true. When you're checking, you're always looking for that end result to be something that's true. Like 0 equals 0, 5 equals 5, 100 equals 100. Doesn't matter what the number is as long as what it says is true. You could also do 7/2. It gets a little more fun with that fraction, but it's also going to give you something that's true. It would say 49/2 equals 49/2. These were the two examples I've got. Coming down here, I am just going to have you do number 3 as your practice one. So go ahead, pause the video and try that now. All right, so while you were trying this one, I was writing it all down so you don't have to watch me struggle. So for number 3, we want to start off by setting it equal to 0. So I was subtracting x on both sides and subtracting 1 to make that happen. When you do that, x minus x cancels, 1 minus 1 cancels, so you're left with that 0 you want. On the left side, you get 6x squared. 5x minus x gives you that 4x. And then negative 1 and negative 1 gives you that negative 2. Once you've got that, you can see that a is 6, b is 4, and c is negative 2. Don't forget that negative that goes with it. After that, we use quadratic formula to substitute those 3 numbers. I've got x equals negative b, so negative 4, plus or minus square root of b squared, so 4 squared, minus 4 times a, which is 6, times c, which is negative 2, all divided by 2a, which is 6. Once I've got that, I'm just going to work on simplifying the square root. So inside that square root, I said 4 squared is 16. And then negative 4 times 6 is negative 24. Negative 24 times negative 2 is 48. So we get that positive 48 there, all divided by 2 times 6, which is 12. From there, I'm still working on that square root. So I say 16 plus 48 is 64. And then I can say the square root of 64 is 8. So we get x equals negative 4 plus or minus 8, all divided by 12. Because I finished my square root, now I can go ahead and rewrite it using that plus or minus sign. So one of my fractions says negative 4 plus 8 over 12. The other one says negative 4 minus 8 over 12. The last part is just figuring out what those equal. Negative 4 plus 8 gives me 4. So we get 4/12 or 1/3. And then negative 4 minus 8 gives me negative 12. Negative 12 divided by 12 gives us negative 1. Whoo! The more of these you do, the more you'll figure out like which steps for you that you need to keep in, that you really need in order to be successful with these problems, and which steps you can skip. For example, some people skip writing out the A, B, and C. They just look at here and see A, B, and C. If you skip this step, just be real careful with the signs. For some other people, they might skip copying down the quadratic formula. You'll figure out what works best for you. But be careful. Don't try to skip too many steps, because that's when stuff starts getting messy. I've got 2 last ones here. Starting off with number 5, I encourage you pause the video and see how much of number 5 you can get through on your own before we do it together. So for number 5, I want to start off by setting it equal to 0. I'm going to do that by subtracting that 2m squared on both sides. I'm going to come in here and subtract 2m. I'm going to write squared like that. We've seen that before. It's called a caret to show that it's an exponent. So I'm going to subtract 2m squared on both sides. When I do that, I am left with negative 2m squared minus 4m plus 7 equals 0. There's nothing over here I can combine since they're all different. None of them have the same variable and exponent. So we've got it now in my quadratic equation form, set equal to 0. I do want to point out, notice that negative 2m squared, I put that in the beginning. Why would I want to do that? You could put it on the end. You could put it anywhere you want, really, on this side of the equation. But I put it at the beginning so that I've got it in quadratic equation form. Remember, all the way back here, we said usually that x squared you see first, then the x, then the number. That's the order we follow. So here I'm just keeping it in that order. Once we've done that, I can see that a is the number negative 2, b is the number negative 4, and c is the number 7. Once I've done all of that, I can use my quadratic formula. I'm going to copy all of this. Please be nice to me. Yay. I've got it all copied, and I can substitute my numbers. So instead of negative b, I can say negative 4, or to make it easier, just positive 4. Instead of b squared, I can say negative 4 squared. Instead of minus 4ac, I can say minus 4 times negative 2 times c, which there is 7. And then instead of 2a, I can say 2 times negative 2. Just like those past problems, I got to figure out what all of this here equals. And just like those past ones we've done, I'm going to focus in on figuring out that square root part first. So inside my square root, I've got -4 squared. What does that equal? Well, -4 squared, remember, is -4 times -4, which is going to give us a +16. After it, we've got the -4 times -2 times 7. What's that equal? Well, -4 times -2 gives me +8, and +8 times +7 gives me +56. And then in that denominator, 2 times -2 gives me -4. I'm almost done to figuring out that square root. So we're going to do this again. Inside that square root, I got 16 plus 56. What's that equal? Well, 16 plus 56 gives me 72. And then our last step is always figuring out what that square root equals. Uh-oh. Well, wait. We've got the square root of 72. Is there a square root of 72? No. This problem is different than the other ones we did because for all these previous problems, when we got to that square root step, I was able to take that square root. Every single time. Square root of 9 is 3. Square root of 49 is 7. Square root of 64 is 8. Here we've got the square root of 72, though, and there is not a square root of 72. So that is what makes this problem different from the others. Now, what it doesn't mean is it doesn't mean I can't finish using the quadratic formula. It just means our final answer is going to look a little different because I'm not going to be able to get rid of that square root sign. It's going to stay in my answer. There is something else we can do, though. Square root of 72. You've seen that before, and you saw that in the last lesson, which was on simplifying square roots. Now it makes so much sense why we had to learn how to simplify square roots before doing this lesson. In order to finish figuring out what our variable equals, which, look, again, I've got it equal to m, but the equation has m in it. In order to finish figuring out what m equals, we're going to need to simplify that square root of 72. Now, there's a couple different ways we learned how to do it. I'm going to choose the way where you rewrite your square root using a number you can square root. So I'm going to rewrite 72 as a multiplication problem using the number 36 times 2. And I chose that because 36 is the biggest number or the biggest factor of 72 that does have a square root. So when I do that, I could say, well, the square root of 36 is 6, so it no longer needs a square root. Square root of 2, there is no square root of 2, so that's going to stay inside our square root. So we get 6 square root of 2. That helps me out because now I can rewrite this using that simplified square root. So I'm going to put it down here, and instead of saying the square root of 72, I am going to say 6 square root of 2. I'm literally changing square root of 72 to that simplified square root. Now at this point, we want to check and see if there's anything else we can do. Sometimes you can simplify the square root, sometimes you can't, so you might have to stop here. We were able to simplify the square root, so this might be the stopping point. There is one other thing we can look to see if we can do, and that has to do with this divided by -4. Now, looking at what we're left with here, I've got 4 plus or minus 6 square root of 2 on the top. We cannot add or subtract those together. It's kind of like, it's almost like a variable. You can only add or subtract those if they both have the square root of 2. And since they don't, they're going to stay separate. But what we can do in this problem is we can divide by -4. Another way of thinking of this problem is, since that division line goes across the entire bottom of the entire fraction, this is the same thing as saying 4 divided by -4, and then, oh no, plus or minus. Go into the equation. Plus or minus, there we go. Plus or minus that 6 square root of 2 all over 4. All over -4. So the division line just means we're dividing both of them up. Now the reason I've written it like this is because I notice I can divide these and I can simplify this fraction here. So we could take this even further by saying, well, 4 divided by negative 4, that's negative 1. 6 square root of 2 over negative 4, I can't necessarily divide all of that out, but I can simplify it. I see the 6 and the negative 4. I can divide both of those by 2. So we are left with if I divided both by 2, 6 divided by 2 is 3, and that 4 divided by 2 is 2. So this is another way you could see your answer. All the technology stuff is getting me a little flustered, if I'm being honest. For problems like these, they look weird. Let's be honest. This is the most accurate way you could write your answer. Kind of like when we leave our answers as fractions instead of turning them into decimals. Sometimes the decimals can carry on. This is the one way you could see your answer. Depending on the problem, though, you might want to actually like do all this math out on a calculator and get a decimal answer. But I do want to make sure you know how to represent it as these like weird looking fractions as well. So there's one last one for you to try. Remember that one at the very beginning of class that we could not solve by factoring? We could not solve it by factoring because the answer has a square root in it. So I'm going to have us scroll back on up here, and the last thing I'm going to have you do is go ahead, instead of solving by factoring, solve this one now using quadratic formula. All right, I wrote up to here and then we can do this last part together. So it's already set equal to 0. So A is 1, B is 6, C is 4. I substituted in those numbers and got this. Did some math. The 6 squared gives you the 36, and then the minus 4 times 1 times 4 gives you that minus 16. 36 minus 16 gives you 20, so we're left here. Just like that last example, we're left with a number that does not have a square root. We can simplify it though. The square root of 20, I'm going to change it up. I'll do the factoring tree method. That would leave you with 4 and 5. And then for the 4, that's a 2 times 2. So for prime numbers, we get 2, 2, and 5. I've got a pair of 2s, so that goes outside. And then the 5 is by itself, so that goes inside. So we get 2 square root of 5. So I'm going to take all of this and just replace that square root of 20 with 2 times the square root of 5. So I've got my negative 6 plus or minus. Instead of square root of 20, we're going to write 2 square root of 5. And then all of that is divided by 2. Now again, that line going across everything means I can divide both of these terms by 2. Negative 6 divided by 2 gives me negative 3. And then we've got our plus or minus. The 2 divided by 2 gives me 1, so we get 1 times the square root of 5. You got to this part here, that is awesome. The one thing I would improve upon even more is that 1 right there. 1 times the square root of 5. Well, 1 times anything is just itself. So 1 times the square root of 5 is the same thing as just square root of 5. Again, kind of like a variable. We don't need that 1 in front of it. This is as far as you can go right here. You could write negative 3 plus square root of 5, negative 3 minus square root of 5, but you're not going to be able to add or subtract these since this is a number and this is a square root. You can't add or subtract. So this is as simplified as it gets. So earlier when I asked you to solve by factoring, the reason you couldn't is because this is what the solution looks like. That is everything I've got for you for this lesson. Thank you so much for watching. Please reach out if you've got questions on these. These are a little crazy. Do know, though, that tomorrow's lesson, which is November the 24th, which is a Tuesday, we're going to be reviewing quadratic formula a little more and talking about how you decide when to solve by factoring, when quadratic formula makes more sense. So we'll have more review on this tomorrow as well. Hope to see you in our live class tomorrow, but that is everything for today. Thanks. Bye.